Hello, everyone. Welcome to the Calculate Evaluation Order session. My name is Renato Lira. I'm a data platform MVP based in Brazil, and I just came from the self-sufficiency part of this world, and I just love and the DAX's languages. You can contact me on social media. Feel free to reach out. I'd be glad to talk with you. So this session is not intended for beginners to talk about calculating just 20 minutes, just not enough time, right? So there are some prerequisites. You need to, of course, have prior experience with the DAX language. You have to know how to read variables, and of course, have used calculate before. First of all, I'd like to thank the giants that inspires us, especially SQL BI. They have a couple of articles that I use those concepts here on these presentations. And don't be fooled if whenever you see, let me put the laser part here, on August 2020 dated, because one of those I know is at least more than 10 years ago. So they're doing this kind of stuff for a long, long time. And as well as their external tools that we pretty much use every day. And if you don't, use it. You're going to have some productivity boost by using most of them. And of course, Jeffrey Wang, for one who don't know him, he is one of the fathers of this beautiful language called DAX. Please, Jeffrey, keep blogging. This specific blog is from 2011, and he just recently blogged about the new window functions. If you didn't see it, it's a must. Apart from Greg, which is a Microsoft MVP, everybody can agree that calculate is the most important DAX function. You can change or restore some filter context, and it performs context transition. And from now on, every time you read, think, or speak about context transition, you have to think that it's a context transition from an active row context into a new filter context. And calculate is implicitly present within measure calls. That's especially important when you are activating some context transition. Most people actually don't realize they are doing that. DAX is a functional query language. It queries its data model. But how does it evaluate the parameters? In general, most functions is like Excel. You have a generic function, first the first argument, and then the second, and so on. But calculate is slightly different. It first evaluated all its filter contexts, performs, so it can determine a new filter context, and then, as a last step, it evaluates the expression. That returns a scalar value if you're using calculate, or a table value if you're using calculate table. So let's just do a quick recap of calculate filter or calculate modifiers that you can put on that. Calculate filters allow Boolean logical comparisons. As soon as you're comparing columns within the same table, it can transform this Boolean logical expression into a table, which is the main kind of filter that you can pass through a calculate statement. There's also filter modifiers. The first one is keep filters. Keep filters accept the same kind of argument, can be a Boolean expression or a table expression, but it changes the default way of filter propagation that we're going to see a little bit further. We also have the remove filters or the group all. That's like a rubber. We can erase some previous filter that might have been active, so we can calculate a specific expression. Sorry. And we have model modifiers. We are no longer talking about changing filters. We're talking about changing the model. That's really important distinction that I honestly don't see much people talking about. And by the end of this session, I think we're going to be clear why we have to separate the model modifiers from the other ones. And context transition, if existent, it doesn't affect filter evaluation at all. Okay, let's do a little summary about the tables. They are the main kind of filters of calculate. You filter a lineage. What is a lineage? It's the full address of a column that resides in a table. So the most recommended part is to filter a single column, because you're going to have a smaller table and less materialization. Therefore, you're going to have better performance. You can, but you absolutely shouldn't filter more than one column at the same table filter, especially if those columns, those lineages, they're synonyms, they become from different tables. You can get out of hand with that, okay? So be careful. And we can put a whole table over there. I have, in this little model, a table, which is a fact with the mentors. And I have a dimension with some continent dimension. So how do you read that kind of filter? First, this is the expanded version of the mentors table. Every time you write a code that says, oh, that's a table of my model, it always will become with the extended version of this table. So the filters here are, the name has to be Alberto, and the gender male, and the country Italy, and the country Italy, not only for the fact table, but now for the dimension table and continent Europe. There's a logical end between the things within the same row. And for each other row, it's the OR logic. This is very expensive, especially if you put in some fact table on your calculate filter. So don't use the best practice and so filter one column at a time. Okay, DAX is a query language for a model. So you need to look your model at all times. All times. This is a really small model with one fact table and two little dimensions. The models can become really, really big, but we need to look at our model at all times. And within the model, whenever you reference a table, there's such things as expanded tables, which depends on the kind of relationships you create between those two tables. You can use a regular relationship. You can use a limited relationships. For you who don't know what regular or limited relationships are, I suggest you to look up for Microsoft documentation, which is of the paramount importance for us to master calculate filters and how they are propagated. Because the standard way of filter propagation is through extended tables, and they depend on what type of relationships you are creating. And there's such thing that I call the power matrix, the context evaluation matrix, aka power matrix, which is a synthetic way to represent your model. Again, this model is really small, but it can become a lot larger, and you can quickly see those are 4 different versions of the same set of tables. I'm just changing the cardinality and the filter direction for only one table. So the map becomes really different between them. So this power matrix, with it, you can see for each lineage, if that lineage is present or not on the expanded version, or if that lineage is capable of filtering a specific base table. So it becomes more clear to use the power matrix to actually see the model at all times. So let's just pick the standard, the regular relationship, and our power matrix will become more simple. And with that power matrix, we have the model representation, as we already said. So most DAX queries are originated in a report. So the report, the engine that runs the report, will see all the filters and make a DAX query to return the results and then to be rendered into your beautiful visualization that you have. But each number will be like a waiter. I call this character Tom, and he will write an order. And here we have 8 orders. And this specific order has a query context. It iterates over an internal filter that says this state is this and the source is that. Sorry, the slides the pictures are in Portuguese, but I think you can get the idea. Okay, so those 8 orders are randomly assigned to someone that I call them Daxers. They are somewhat between formula and storage engine at the same personage, so that's why I unified it. And one of that order can be assigned to a Daxer. And this Daxer, first thing, he gets the expression and he has to evaluate what the current filter context is. So he looks up the power matrix, and for each lineage on your model, it puts an arrow and sees it. Whenever there is a value or there is a filter, it stops. And whatever is behind that value gets blocked. That's the blocking semantics, okay? Oh, so this concept was introduced by Jeffrey in 2011 and says that whenever the filter are closest to the Daxer, it blocks everything behind it. So it won't, any previous filter gets blocked if there is something on top of it, okay? And if there are no, the arrow goes through, there are no filters, simply you don't have any filter applied to that lineage, okay? So here, there are only 3 filters active here. So what if we have a nested calculate? So we have an outer calculate and an inner calculate. As we said, the expression for the outer calculate is this one, and we have only one logical Boolean filter. What do you think the filter context will be? Will be every date? What's the answer? Or do you think it's going to be 2017? Most of people didn't raise their hands, so it's hard. You need to get used to read calculate statements, and after some time, it will become clear. The answer here is it first puts the filter over the year, and then it removes the filter over according to the all that removes the filters. So when we take our power matrix with its model representation and context evaluation, it has the middle part, which is the DAX query. It's aware of the external filter context, what columns they are putting internal filter context. And for this expression, we have the nested calculators. This time, we first put 2017, and then we remove all the filters. So when the time Daxer comes to evaluate the actual measure and sees it, everything gets blocked, and it's going to calculate over no filter at all, okay? But what happens if you change the order between the inner and the outer calculate? We change the order, so we change the order of how we put the columns over our power matrix. So now Daxter sees only a filter from 2017 and blocks every other filter on the calendar table. Okay, so it's a more visual way for us to see how filters are stacked up between each other. So I'd like to highlight the importance of this power matrix, because with power matrix, we can see the model, the query filters, and the internal filters that your expression might have really clearly, really easily. And whenever we use an all or remove filters, it removes filters from every lineage, every column that is present on its expanded version. And the power matrix helps us with that too. Okay, but the main topic of this session, and about the power matrix, there is a topic for us to go deeper, but we don't have enough time. It's theme for another session. And what happens if we have multiple filters within the same calculate? There's no outer, there is no inner calculate, multiple filters within the same calculate. So there's a generic expression with a measure and several kinds of filters, and you can read this single expression as this bigger one. So it's bigger, it uses variables, but once you know how to read nested calculators, it becomes way more clearer, less verbose, and more visual way to visualize these kind of things. Sorry. So here, I have 3 table filters, or 3 Boolean filters that internally are transformed into tables. Those filters, they first are, sorry for the English, I first wrote it in Portuguese and then wrongly translated. So those three filters are assigned to a variable. They are materialized. And if there is any row context active, this row context is actually translated into a new table. And remember, context transition is performed under the expanded version of this table. So the filters are evaluated, the context transition, if existent, is evaluated too, and this first block, those are the filters. I don't know which one will override or add to the other one, but those are the filters, those are the variables. And then we can zoom it a little bit and take those filters, and first we apply the context transition. We know that we can override context transition, so it is the weakest one. It is put it on the outer calculate one. So in the next level, after the context transition is performed, we can ignore some or all of those filters, okay? And then we have the regular filters, the most common that we write within calculate. That regular filters, they might have more than one. And between them, within the same calculate filter, they have no override power between each other. So you might think, if you have multiple, they are like an intersection between T1 and T2 right here. But there's that special filter modifier called tip filters. It is applied, but it do not block any previous filter that might have been applied to that lineage. So tip filters is like a transparent filter. Just add that filter, not block or change completely that filter. And as this finishes the part that we do the filter evaluation. Okay? When we can read the outer, the inner, who takes precedence to what, we can actually evaluate it. The filter context that I'm talking about it is this, all right? And it's really important that this filter is evaluated under the current model. Whenever you put all or remove filters, some fact table or some dimension table, it is taking account of the current model. If you have one model modifier over your calculate, it didn't took place yet, all right? It will be taking place later on. So it's really important for us to differentiate between those kind of things. And as a last step, it evaluates its measure. We all know that there are calculation groups that they can change the expression to some other pattern that you might have. And whenever within the filter context, there is a filter that activates an calculation item, it might rewrite your query for you. If you don't, it just evaluates the measure under those filters that we previously talked. Either the filter modifiers one and the model modifiers ones. All right? So this code is available at GitHub at this address. Please, every single scenario that I've encountered, and I'm an internal consultant on my company, so I take a lot. This diagram helped me to diagnose the problem and correct it. And if you find some specific scenario that it doesn't, or you think it might enhance, please contact me so we can further improve this visual, less verbose calculation evaluation order. Okay? And a wise man, Bernard, unfortunately he isn't here with us, he said, okay, I got it. I don't always have your GitHub on my side, I have it printed. So whenever I'm in doubt, I see and reach out to the conclusions. But whenever you're in doubt, you know, you can always nest your calculates. So you force the order. Okay, if I need my model to be changed first, and then to add some filters on top of it, fine. You can, in your expression, nest calculates, so the order becomes more yours and less from the engine. Okay? I'd like to thank you. Unfortunately, we don't have time for questions. I can be outside to answer if you want. And please, this is my first in-person international talk. English is not my first language. Give your feedback, especially with words, not just numbers, to help us improve and give further talks and other sessions here. Thank you very much.